Before we start this video, I want to inform you that the first part of the video will be without any type of voice. This is because I unfortunately got sick a little bit before Christmas, and yeah, my voice was basically in no good to actually talk, but I still wanted to record something. So for the next controller, I will put some text down to give any type of context about the repair, and hopefully by the next controller I will start talking again, so it should be a little less quiet. But yeah, then you know that. I hope you can still enjoy the video. So here we are back with controller number 9, as we can see here. And what was wrong with this controller is that the controller gave no response at all. So when we connected it to the computer, we could not read it, it would simply not connect. So I think we suspected that it might be a USB issue. So as you can see, I already grabbed a replacement USB. I will be replacing it. And before I hit record, I already did a bit of a visual inspection around the board, and I also looked at the USB port a little bit closer up, and as you can see, it doesn't really look too bad, but you can see that the clasp, I think you say, and on the upside of the USB port is a little bit opened. So maybe this USB port had a lot of USB cables being pushed in and out, so that can definitely cause a bit of wear and tear on the controller, and thus it not really connecting properly or not at all. I did already grab the multimeter and check the pin outs of the USB port and see if it goes everywhere it should, and it does go everywhere it should. So yeah, that makes me think that if there is a problem with the USB port, it's more so on the front of the USB port. And also, just to be sure that the motherboards don't have any major faults on them from the start, I also already went over some of the capacitors and see if any of them are shorted, and I did not find anything. So I think our second board is okay for now, so we do not need to worry about that. And we can just focus on replacing the USB port and see if that solves the problem. Which would be really nice, considering this is the last controller we will work on in this series. I do have another motherboard, which I worked on briefly in an earlier episode, but that will be a separate episode because I want to install some Hall effect sticks into that motherboard. So yeah, let's hope we can finish the series with a fix. But yeah, first we need to get the first motherboard out of here, so we need to take this Xbox controller apart a little bit more. So we need to take out a couple of screws, and I will be using a T6 screw bit for that. And next up we need to grab the soldering iron and desolder the rumbles off of the motherboard. And as you can see, the solder is a little bit shiny on this red wire and on the black wire right here. So this might suggest that someone has been in here before. Unless these are factory solder joints, but they look a little bit too shiny for that to be the case, I think. Which is pretty interesting, because the sticker on the back of the controller was not opened up at all. It looked pretty factory to me, but I don't think leaded solder is being used in the factories nowadays. So yeah, I suspect that someone may have been in here before, but yeah, did that really cleanly, I guess, which now that is good for me. But yeah, let's take off the rumble motors. And also, you can see that one of the back grips has a lot of damage. So if we can fix this controller, we need to replace this, because, well, this is not very desirable. Of course, I have a couple of spare controllers, so if we can replace that, that would be absolutely great. Okay, so now we can separate the first motherboard. And I mean, the controller itself is pretty clean. This looks all very good. in good shape, so I don't think we have too much work in cleaning this up. Let me put the buttons back. But yeah, in comparison with some of the auto controllers we've worked on, this is looking pretty good, which I'm happy with. And also the motherboard itself is looking good. There's no tears and such in the motherboard, so that's all good news, obviously. Okay, I will try to switch you over onto the microscope right now, which I recently got a new stand for. So I hope this is all working well and the view is good. We need to move the main camera out of the way. Okay, I should be recording onto the microscope right now. And here you can get a better view of the USB port. And as you can see, the back looks pretty good, actually. That is a little bit too thick. Let me get a smaller pair of tweezers and see if I can touch each of these. I mean, this is all perfectly solid. It's all connected really well. I will go over to the multimeter in a second. Let's see if I can focus this. Yeah, there we go. Let me flip it. I mean, it doesn't really look too bad, but if you look at the very front of the USB port, here you can see two shiny parts, and here it's all a little bit gone, which may explain why the USB port doesn't connect. For comparison, I will get the replacement port and hold them on top of each other. And yeah, here you can see that the replacement board does have the pins shining through nicely, and that's definitely missing on the original port, so that can definitely explain why it will not connect as it should, which is pretty nice that there is a direct reason why this USB port may be bad. I mean, to be fair, I would not have seen this without the microscope. But yeah, I think we have a very valid reason to start with replacing that and see if the motherboard will connect after we do that. So let me zoom in again. I mean, I'm really happy with the new stand for the microscope. Maybe I show a picture, but I have an Endon-Star 409, I think. And that one, the microscope comes with a stand as a default option, and I don't think Endon-Star really has a floating stand for it, but yeah, it was really annoying to set it up and then to take it down again when I'm done with the recordings. Yeah, now I bought a third-party floating stand, I think from AliExpress, and it fits perfectly, and it's so much easier to work with and to move it around and such. It's really a lifesaver. So I will try and do the USB port replacement on the microscope. I will need to lift it a little bit. So let me get it set up, and then we will use the same process as I did in previous episodes, which is to first desolder the ground legs, which you can see right here. 4 ground legs right here. So I will desolder it first with the soldering iron, and then after that I will flip the board around and heat from the top of the board, and then that way we will take the old USB port out, and after that I will just resolder the new USB port in. And I think this time I may actually prep the USB port, so I will put some solder on here beforehand, since it seems to have some difficulty with solder sticking to the pins. So yeah, if I prep it, that should be a little easier to get it to connect to the motherboard. Let me get my motherboard holder, which is right here. See if I can get it all under the microscope. So I've got the motherboard set up in the motherboard holder, and there, as you can see, it fits all nicely under the microscope, so I'm really happy with that. So let's now start with desoldering the ground legs of the USB port. So now that we prepped the new USB port and we moved the solder from the ground legs of the old USB port, now we are going to remove it at the hot air station. And temperature, I think the temperature I will use is 400 Celsius and airflow speed 4 out of 10. I will do. I don't remember what I did last time, but yeah, let's start there and see how it goes. So as you can see, the USB port went off relatively easy. I will now carefully try to remove some of the flux we have on the board. And I say carefully because the last time I went to replace the USB port, I accidentally knocked off a couple of components. So just make sure to stay around the USB port. The old port went off really nicely. Even the plastics have relatively survived, so I think so far this has been the best USB port replacement I've done so far on this type of controller, which is pretty cool. So what I will do next is I will get the soldering iron again at 350 Celsius, and I will just clean up the old pads of the solder you can see here. And then I will grab the new port, and then we will start by resoldering the ground pads from the other side of the motherboard. And I will probably use some super glue again to reinforce this port, because I will need to use hot air to reinstall it, but I don't really want to do that, since I'm not very confident that the diodes on the back of the board will survive, since I will need to heat up from the back, because I do not want to burn the new port. So I will just drop a little bit of super glue right here, and then the port should still be perfectly fine. But yeah, we remove the solder from the ground legs. Since the board is hot, it's really easy to do. I will also turn off the heat gun in the meantime, or the hot air station I should say. So now we will clean this up again. Some IPA and a Q-tip. Can be a little bit more rough since everything around has now settled down again, so we will not knock off any components. There's a little bit of flux on the side, which doesn't really want to come off that easily. It doesn't really matter that much, but it's nice to get it as clean as possible. At least I'd like to do that. Well, I think I should be happy with that. So what I'll do next is, like I said, I will put a drop of super glue down, so that can strengthen the USB port in the future, since these are a little bit fragile. So that should be plenty. So now we have the replacement port. We already prepped it, as I showed earlier. Now we can just reinstall this in here without any problems. Push it down a little bit. So we need to make sure that it's completely flush with the motherboard. And I think that is pretty good. That's perfectly fine. So now we turn around the motherboard again, and we can start by resoldering the ground legs again. So now I'm taking the soldering iron, and we will use it at 350 Celsius, and no flux is needed, since our solder actually already contains some flux. So if we work quick, then this should be sufficient to fill the ground holes with some solder. So ground holes are done, all looking nice and shiny. So now we will flip the board again, and we need to take care of the 5 pins which are tucked under the USB port. So it's a little tricky to get the soldering iron in there, but I hope with prepping the USB port already that it's a little bit easier to get the job done. So we flip the board around and I need to resolder those 5 pins, and I will use some flux this time around to make sure that it flows a bit more nicely and hopefully helps with connecting the USB port to the motherboard properly. I'll also use a minimum amount of solder to hopefully prevent any bridging from happening. This may still be too much, but yeah, let's try this. I'm not sure if the solder is actually reaching the pins, so I will add some more. I'm not convinced that the solder is transferring to the pins. I think we've heated up the pins, but I don't think it has connected. So I will just go over the pins, see what happens. Yeah, you can see it completely loose. This one may be connected. That one as well. I think that one is connected as well. And that one is as well. So I mean, I think prepping the USB port has been more effective than I expected. So then heating up the pins with a little bit of flux is sufficient to connect it, but yeah, I really want to get some solder on. So I will just go over them again. It's just a bit of a downside that the pins are right under the USB port, otherwise it would have been easier to turn the soldering iron like this and then go over it, but you risk bridging everything, and that is a bit of a pain to undo. So I would just press down on the soldering, on the pins with the soldering iron, and hope that way I can ensure a strong connection. So let's see how the USB port is connected now. If it made any difference for the first pin. Yeah, that is definitely connected. Ooh. Yeah, that's a good connection. That's a good connection. Good connection. Good connection. And a good connection. Yeah, this is fine. I'm happy with this. So one more last thing I will do is, you see these ground legs, and they are connected from the underside. But I will put some solder right here to ensure a good connection from the upside. I will also try to get some here. Maybe a little bit on the front as well, but I need to make sure that I do not accidentally put some solder in the connection, which can happen if I put too much there. So at least as long as the back is well connected, I'm happy. Okay, that was not the intention. I guess this is pretty well connected now. I think I should have turned the motherboard around. I think I can get away with leaving that there. I mean, it definitely makes it more solid, so I will take it. So let me turn the motherboard around and try again on those front pins. The perspective on the microscope is really screwing with me. That's why it looks so fidgety. Well, let's see if I can connect this blob. It did, but I hope it did not go into the connector. Now let's do the other side. Oh yeah, I think that may have gone into the connector, which is not what I wanted. But yeah, let's check under the microscope and I turn it. Yeah, it went into the connector. That's all good. That is not good. So I will need to fix that by getting a little bit of soldering wick or just a desoldering pump and removing that. And not touch the plastic. Very important. So I've done my best to remove as much of the solder as possible, and here very zoomed in I think. Yeah, I have a USB cable. If I plug it in, you can see it does fit perfectly fine, so that is definitely good news. So I think we removed sufficient solder that is well, so that this is not going to cause any problems in the future. I mean, if that one fits, then the other ones should fit as well. So I'm very happy with that. I will clean it out a little bit more properly. It's some contact cleaner from WD-40, which is made for motherboard. So you can spray it on motherboards. So this is not the standard stuff which you can get from WD-40. But this is actually compatible with using on motherboard. I think this is the best it's going to look. I will put some IPA in. Yeah, I'm happy with how that looks. So now let's focus on the rest of the motherboard. So yeah, this is the end result of the USB port replacement. I'm happy with that. So one more thing I want to test before I start putting it back together. That is if the connections are all intact, like they were before I replaced the USB port. So I don't think you will see the multimeter. I will use my multimeter in continuity mode, so I can check the connections of the USB port. If it beeps, it means there is a connection, which should be good news. So let me first go to ground, and that is good. This is ground. The other ones shouldn't connect. Which they don't. No, they don't. That's good. So we know the ground is okay. Now let's check this one, which goes to the 15 right here. That's good. The middle pin goes to this resistor. That's good. The pin next to that goes to this resistor. Also good. And this one goes to right here, to this capacitor, which is also good. So this should be a proper replacement of the USB port, which is good news. So now I will go under the microscope. I will stop the recording and get the microscope out of the way, which with the microscope stand is very easy to do. Now I will get the phone again. It allows me to. It does. So here we have the USB port and the motherboard. What I will do next, that will probably be off camera actually. So I will just give this a bit of a wipe off, a simple clean. This is the cleanest controller I've come across so far in the slot, which is really nice. So I think I will only need a brush and brush it off a little bit. And I will find a replacement back piece for this one, hopefully. And in the next part, I will completely reassemble the controller. And I hope in the next part we get to test it and see if it works. I will not do any testing beforehand, so it will be a surprise for me and you if this is working. Actually, since I did not get it tested at all, so maybe the analog sticks are no good. Then we need to also replace these, obviously. But yeah, I will give it a quick clean, put it together, and then we are going to test it on the computer. Or maybe we are not going to put the board back together. So you remember at the beginning of working on controller number 9, I looked at the motherboard with the USB on it, and I said that there's nothing wrong with it. Well, it turns out that on the motherboard with the analog sticks, there was a very similar crack as on the motherboard, which was completely shorted to ground. So I had to do a trace repair on this controller, and the reason why I went ahead with a trace repair is because I could not find any shorts on the motherboard itself. I think I already said it at the beginning of this repair. So since nothing was shorting to ground, it just meant that the traces were not connecting, and by fixing the traces, that hopefully the board is going to work again. So I think you might be seeing some footage of it on a microscope. I only recorded the beginning and the end of the repair. In total, the trace repair took me over 4 hours of getting a grinding pen, removing some of the solder mask, then tinning the exposed copper, and then getting a wire soldered onto the trace, and then immediately putting some solder mask over it again, so I don't accidentally put two wires together, since it's all very closely together and you do not want to start all over again with doing the soldering work. So I had to take my time with it, and that took more than 4 hours. So first I only worked on the underside, so on the side with the analog stick. But later I also found that at the main chip, that there also were similar cracks. So I had to also fix those, of course, with some trace repair. I only have a picture of that, which I will show right now. After all of those trace repairs, I did put the controller fully together, and I did not test it in between. So now you will see the footage of me trying to test it on a PC and see if it works or not. So as you just saw, controller number 9 is fully working, which I am very happy with after all that work with the trace repairs and of course the USB replacement. So I'm happy that essentially that was the problem. And yeah, with controller number 9 fixed, it marks the end of this series, where the end result is that 4 out of 5 controllers were fixed, or technically 4 out of 4, because there was one controller which I saved for a different video. So controller number 9 was fixed, and controller number 7, the black controller, then the red controller, and controller number 1, which I put in the shell of controller number 3. So controller number 2 was a no fix, and the controller on the bottom right was also a no fix. One because of water damage, and the other one had severe cracks in the motherboard, which caused everything to short together. So there's nothing I could do about that, unfortunately. But of course it does leave me with some replacement parts, which is very useful for me because I have not really worked on these Xbox controllers. So parts are always welcome, obviously. So I don't think we did too bad with all these different controllers. We had quite some different faults, I think. I mean, one was a USB replacement, or two at least. I don't really remember what we did with the other controllers, but I had a lot of fun working on these controllers. It's a little bit different for me because I normally work on PlayStation controllers, and of course Xbox is a completely different ballgame. What I've found is more difficult is to take it apart. It's completely different how it is, because on the Xbox you have a front and back shell, and then all the buttons and the motherboards are all nicely together in a different shell. And in the PlayStation 4, if you take off the back, then you are immediately into the controller, and there's only one screw you need to remove, and then you can access almost everything. So that's a little bit different, but at least a lot of fun to work on these controllers. So I will for sure look out for more faulty Xbox controllers in the future. And yeah, maybe I want to talk about what I want to do with the controller, which I saved for a different video. So in the past, last year, I made a video about a PlayStation 4 controller in which I installed Hall effect sticks for the first time. That video did really well on this channel. It's, I think, about 30,000 views as we speak, so very impressive, and I'm happy that this video is doing well and it's helping people out. So that made me curious how Hall effect sticks in the Xbox work, because I think it might be a bit more work, because for the PlayStation 4 and 5 controllers you have a calibration program you can use to calibrate the Hall effect sticks, but for the Xbox you don't really have anything for that, at least not for the Xbox One. I think with the Series controllers you can use the Xbox Series S or X to calibrate, but there's not really a computer program. So I think I need to do a lot of manual calibrating, which is going to be interesting. And also curious if it is more difficult or easier to take off the analog sticks in general. So I'm pretty excited for that. I hope to get the video out this month, but I don't like to make promises. So I mean, if you like to see it, then maybe subscribe to the channel and you will see the video in your feed soon. And yeah, I hope you enjoyed this series as much as I did. I mean, the controllers which I fixed, I will probably just sell them. I think you can find a link in the description which goes to my eBay account. If you're interested, you can take a look. There's only one controller online as we speak, but I think I will also put the other Xbox controllers on there. So yeah, if you're interested, take a look, only if you want to. And I want to thank you for watching this video, and I will see you in the next one. Have a good day.